Can you believe it? Astronomers have just discovered a mysterious cosmic ocean out in deep space, an ocean made entirely of liquid water. And get this, the amount of water in this cosmic ocean is 140 trillion times greater than all the water on Earth combined. At the heart of this incredible structure is a supermassive black hole with a mass roughly 20 billion times greater than our Sun. Now, back here on Earth, we know that oceans cover about 70% of our planet's surface, and despite decades of exploration, humans have only managed to explore about 5% of Earth's oceans. But recently, scientists made an astonishing discovery. They detected a massive reservoir of liquid water, like an ocean, surrounding a quasar more than 12 billion light-years away from us. And after studying it in detail, they confirmed the liquid water contained in this cosmic ocean is 140 trillion times the amount of water found on Earth, and in the center of it all, a black hole 20 billion times more massive than the Sun. To put that into perspective, this particular quasar can emit as much energy as 10 million trillion suns all at once. Just to note, because this quasar is so far away, what we're seeing is actually what it looked like 12 billion years ago. Essentially, it's baby pictures. What it looks like now, we have no idea. Still, this is by far the largest and most distant body of water ever discovered in the universe. Part 2. Where did this cosmic ocean come from? So how did this gigantic cosmic ocean even form? Scientists believe the environment around this quasar is very unique, one capable of producing enormous amounts of water. Here's how it works. When the black hole at the center pulls in material from its surroundings, the gas and dust nearby get extremely hot. This creates a massive region filled with water molecules and other gases like carbon monoxide. Part 3. What exactly is a quasar? Before we go further, let's talk about quasars because they're fascinating objects. The first quasar was discovered in 1963, not 1975, as sometimes misreported, when astronomers using radio telescopes spotted an incredibly bright object. It was clear right away. This wasn't an ordinary star, it was far too bright. In fact, it was brighter than the combined light of all the stars in its entire galaxy. These objects became known as quasars, short for quasi-stellar radio sources. Further research showed that every quasar contains a supermassive black hole at its core. These black holes typically weigh anywhere from millions to billions of times the mass of the Sun. As gas and dust spiral into the black hole, they get compressed and heated, releasing staggering amounts of energy. That's what makes quasars shine so brightly, even from billions of light-years away. And because they're so distant, every time we observe one, we're looking back in time billions of years into the past. Studying quasars helps astronomers better understand how galaxies formed and how the universe evolved. Some quasars are especially unique. Some shoot out powerful jets of particles at near-light speeds. Others can even reshape the structure of the universe around them. Part 4. What makes this cosmic ocean so unusual? Back to our mysterious cosmic ocean. When astronomers first detected it, the water was in the form of vapor, essentially water vapor, clouds swirling around the quasar. How big is this ocean? It stretches across hundreds of light-years. For reference, 1 light-year equals about 5.88 trillion miles, or 9.46 trillion kilometers. So we're talking about an unimaginably vast region now. Even though the gas there is very thin, nothing like the air we breathe on Earth, it's still hotter and denser than the gas found in most galaxies, including our own Milky Way. In fact, the temperature in that region is about 62 degrees Fahrenheit, 17 degrees Celsius, but the density is still incredibly low, about 3 quadrillion times thinner than Earth's atmosphere at sea level. Even in space, this is an extremely exotic and rare environment. Part 5. The role of water vapor and other molecules. Why is the presence of water vapor so important? Because it's a sign that this region of space is constantly bombarded by radiation. which keeps the gas hot and energized. Astronomers also detected carbon monoxide and other complex molecules in the same region. In other words, this part of the universe is rich in raw materials for building stars, planets, and maybe even life. So what happens next? Some of the gas may continue feeding the black hole, making it even more massive, possibly 6 times bigger than it is now. Some gas may form new stars. Some gas may be blasted outward, into intergalactic space. And the fact that we're seeing water vapor in a quasar this far away tells us something profound. The basic building blocks of life like water have existed in the universe for billions of years. Water is essential for life. Its presence so early in the universe's history suggests that the ingredients for life may have appeared much earlier than we previously thought, and water plays another critical role too in the process of star and galaxy formation. When vast clouds of gas cool down, water helps them collapse more easily, which leads to the birth of new stars. Let's rewind the clock to 2008. That's when Professor Bradford's team decided to bring out a special tool, an advanced instrument called Z-Spec, mounted on a 10-meter telescope. Think of Z-Spec like a cosmic fingerprint scanner, specifically tuned to detect the unique light signatures of water molecules in space. But to be sure, they were actually seeing water vapor. They needed confirmation. So they teamed up with another powerful array, the CARMA Radio Telescope Array in Southern California. Combined Array for Research in Millimeter Wave Astronomy. CARMA is a group of telescopes working together, like an ultra-sensitive ear, listening for faint signals from deep space. Meanwhile, another research team in the French Alps was also on the hunt, using telescopes to scan the sky for signs of water molecules in space. By 2010, the second team reported spotting a very faint signal of water vapor coming from this distant quasar. But then came the big breakthrough. Bradford's team managed to detect much stronger signals, clear, undeniable evidence that this enormous cosmic cloud really was full of water. Part 3. Water beyond Earth. What about our own solar system? This cosmic ocean isn't the only place where we're finding water. In fact, scientists recently made another exciting discovery: liquid water beneath the surface of Mars. In theory, future astronauts could one day use that water for missions on Mars, or even for long-term human settlement. But here's the catch: the water on Mars isn't sitting in lakes or oceans we can easily tap into. Instead, it's buried deep underground, well beyond the reach of today's technology. So how do we even know it's there? Researchers analyzed seismic data from NASA's InSight lander on Mars. InSight picked up strange underground activity, and the most likely explanation: hidden underground reservoirs of water. Part 4. The mystery of Mars missing water. Right now, Mars still holds some water, mostly in the form of ice near the surface and underground. But compared to the huge amounts of water Mars had billions of years ago, what's left today is tiny, which raises a big question: where did all that water go? Scientists have a few theories. Some water may have escaped into space over time. Some may have seeped deep into the planet's interior, where it might still exist as underground reservoirs or frozen ice. The problem is, we can't yet measure exactly how much water Mars has lost, so the mystery remains unsolved. Part 5. What about the Moon? You might be wondering, does the Moon have water too? The answer is yes, but it's not what you might imagine. There are no lakes or rivers on the Moon. The water that exists there is mostly in the form of frozen ice, and this ice isn't spread out evenly. It's concentrated at the cold, dark polar regions of the Moon, places that never see sunlight. A lot of this ice is mixed in with lunar soil and buried deep below the surface, which makes it very difficult to extract. Part 6. Water on Enceladus, a tiny moon of Saturn. Now, let's talk about Enceladus, one of Saturn's moons. It's tiny, only about 505 kilometers in diameter, smaller than the state of Arizona. When NASA's Cassini spacecraft flew past Saturn, Scientists originally thought Enceladus was just a frozen, dead world. But they were stunned to see something incredible. Geysers shooting out from Enceladus' south pole. Huge plumes made of ice particles and water vapor, blasting straight into space. That could only mean one thing. Beneath Enceladus' icy crust, there's a massive hidden ocean of liquid water. Next up, let's talk about Europa, one of Jupiter's largest moons. Europa is covered in a thick sheet of ice, but underneath that icy crust lies a massive saltwater ocean. Estimates suggest it could be up to 100 miles, 160 kilometers deep. That's more water than all of Earth's oceans combined locked away beneath the surface. Why hasn't it frozen solid? You might wonder, why doesn't Europa's ocean freeze into solid ice? The answer lies with Jupiter's gravity. As Europa orbits Jupiter, the gas giant's immense gravitational pull constantly stretches and squeezes the moon. This friction generates heat in Europa's interior, which keeps the subsurface ocean in liquid form. In other words, Europa stays warm enough beneath the ice to host an ocean of liquid water, despite the freezing temperatures on its surface. The search for life on Europa. Here's the part that really excites scientists. There's a good chance water from Europa's ocean might be escaping into space. How? Through cracks in the ice. Geysers of water may be erupting into space from these cracks. If that's true, we wouldn't need to drill through miles of ice to reach the ocean. Instead, we could fly a spacecraft through the water plumes and collect samples right from space. The big unknowns, of course. There are still a lot of unanswered questions. How much water is actually under Europa's ice? How quickly does the water refreeze once it reaches the surface? How do the extreme temperatures and pressures affect the ice and ocean? Scientists are eager to get answers, because Europa's ocean might just be one of the best places to look for alien life in our solar system. Discovering cosmic oceans, water vapor around distant quasars, and hidden water across our own solar system. This isn't just trivia for astronomy fans. It's actually a major clue in the search for life beyond Earth. Here's why. The presence of water tells us that the essential ingredients for life were present billions of years ago, even in the early universe. In other words, life-friendly conditions might not be unique to Earth. They could be much more common across the cosmos than we ever imagined. Water's role in shaping the universe, and water doesn't just help life, it plays a vital role in shaping stars and galaxies too. When giant clouds of gas in space begin to cool, water helps those clouds collapse, forming new stars and planetary systems. So finding vast amounts of water vapor surrounding a distant quasar gives us new insight into how the first galaxies formed, how stars were born in the early universe. A new chapter in space exploration. These discoveries also open up thrilling possibilities for the future of human space exploration. Think about it. Water on Mars could help astronauts survive longer missions. Ice on the moon could be turned into drinking water or even fuel. Oceans on Europa or Enceladus could one day be explored by robotic submarines, searching for signs of alien life beneath the ice. We're entering an era where these things are no longer science fiction. They're starting to become scientific goals within reach. The big picture by finding vast cosmic oceans of water vapor, liquid water hidden under Mars' surface, ice on the moon, subsurface oceans on Europa, and Enceladus. Scientists now have clear evidence that water, the foundation of life, is widespread in the universe. And that gives us real hope. Somewhere out there, in the vastness of space, life may already exist, may one day emerge.